Last class we have been talking about the term accuracy. Okay? Accuracy actually means inaccuracy. Number one. Number two, accuracy is closeness of the measured value to the true value. That's the definition. That's a qualitative definition. Quantitatively, true value minus reading divided by the reference value into 100. Of course, there is a modulus and there is a max. Modulus is for ignoring the sign because we are computing the error. Anyway, it doesn't matter. But modulus is there. And max is there. That's very important. Normally, students miss when they do computation in their exams. For every reading during the calculation of accuracy, we take multiple readings. We compute some number called accuracy. Out of the error, we take the maximum error. Out of the error, we take the maximum error. That point we have stress tested. So, the definition of accuracy is the true value minus reading. In fact, the modulus of both of the terms, max, the bottom, telling that the maximum difference, divided by reference value into 100. The reference value could be a true value or full scale deflection. We discussed what is true value. Also, we discussed about what is full scale deflection. As a manufacturer, we prefer to use the full scale deflection because when you use full scale deflection, the number seems to be small. So the instrument will look seemingly better instrument. Instrument does not become good all of a sudden, but it seemingly look a better instrument for the buyers. So people use full scale deflection. I think up to that we have seen. Any questions so far, whatever we have discussed? What asked? Clear? Let's take a small. Okay, fine. When we go for accuracy, always know when we say we want measurement, we want reading. You ask how accurate you want. The general answer from the recipient is, you give me the reading as accurate as possible. Okay, but as an engineer, you should not demand unless it is needed for the application, because you will be choosing an instrument in a company, for measuring, let's say, temperature or pressure or distance, whatever it is. You will be choosing instrument. In a lot of suppliers, you will be choosing the particular instrument for your company. You should not ask, okay, I'm going to measure temperature, so give me the best available in the world because I want to have best instrument in my company. That's not the, that should not be your idea. Because every small increase in accuracy that you demand, that's going to have disproportionate increase in the price of the instrument. Okay, it is going to have disproportionate increase in the accuracy of the instrument. For example, I have a lorry full of load. Some manufactured goods are there. I wanted to measure the goods. For example, it's a vegetable, full of vegetables. We packed and we stacked everything in socks and it's all huge. One full lorry load is there. Would you like to have the weight of that vegetable in plus or minus 1 gram accuracy when it comes to a vegetable? Okay. Do you want a weighing bridge with plus or minus 1 gram accuracy or 0.01 gram, 0.001 gram accuracy? Absolutely not. We'll say, okay, plus or minus 2 kg, plus or minus 5 kg is also alright. Right? Whereas, when we weigh and sell the gold or maybe still more precious metal, costly metal, then we will demand, no, my weighing balance should have the accuracy of 0.0001 gram, so that every milligram is 100 rupees. So I cannot afford to lose because of the measurement error. So while measuring gold, probably you will demand a physical balance which gives a better weight readings than a weighing bridge. While the bunch of vegetable you want to measure, you will not look for physical balance kind of instruments, with such precise instruments. So you will go for even crude instrument, as long as a rough idea you get, plus or minus 5 kg difference for the entire load of, let's say, 2 ton, 3 ton of vegetables, it's fine. Right. I have taken an example here. So, for computing accuracy, okay, that's very important. So, if you read, calculate the accuracy of the thermometer, which is measuring a known 350 Kelvin temperature. Okay. So, what is the true value? True value is, what is the true value? Yeah, you all can speak, right? What is the true value? Yes, please respond. 350 Kelvin. It's a capital K. Small k is not okay. Small k stands for kilograms. You have a new thermometer which is to be calibrated, or for which you need to calculate the accuracy. And you have plenty of readings. Say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 readings are there. Okay, it's going to consume quite a lot of time. I do one sample calculation and then tell you the trick so that we will stop the babysit problem. That's not the way to do it. Reading. You have, let's say, first reading 350.1 Kelvin. Okay? I take only the first reading. Is there anything said about the full scale reflection of the instrument? Is there anything said? The data is not given. So what is the only way out for us? What will be our reference value? True value itself we will take as well. So, the percentage of accuracy, plus or minus. True value minus reading. What is true value? 350 minus 350.1 divided by, reference value here is again true value. You should have plus or minus sign. You should have 100, and whatever the number that you compute. What is this? 0.1 divided by 1 divided by 35 is how much? Can somebody help me? One divided by 35. Point 0. 8. Okay. While reporting the result, plus or minus is also important. Suppose in the exam this kind of question is asked. You are computed correctly, you are given the answer 0.028%. If you are given like that, it's a wrong answer. It is a wrong answer. Plus or minus is mandatory to make sense. Okay? Why? What is the meaning of this 0.028? That is the maximum error. Of course, we have not gone to the maximum part of it. First I will stress maximum, probably then I will come to the interpretation of the result or the presentation of the result. Okay, fine. I take the first reading 350.1 Kelvin and then computed the accuracy that happens to be 0.028%. Okay, fine. So I have to compute 52.0, 59.7, 349.0. Like that for all these reading individually I have to compute. For every reading I will get one accuracy like that. One accuracy like that. Let us say the first reading I have plus or minus 0.028%. The second reading probably 0.135 something. I'm just randomly writing some numbers. But actually when you compute you get 10 readings means 10 such numbers you will get. Okay? So plus or minus 0.057%. Plus or minus 0.028, maybe make it repeated because of that. Plus or minus 0.153%. You get like that 10 such accuracies you will get. Okay. our formula is here it is the maximum difference divided by 350 into 100. So out of all these values, whichever the value will give the highest error, the highest accuracy, not highest accuracy, that's not the right term, highest inaccuracy. Okay, what is the highest inaccuracy? 0.13, 0.15. This is 0.01. Okay, so this is the highest, plus or minus 0.153 is the maximum number. This is the maximum number out of 10 numbers. Okay. In spite of all such explanation, people normally make mistake here in the exam. That's why I know I give a lot of stress there. So pay attention. Out of all the numbers I have computed, take the maximum number and view that as the while presenting the result, the same result, plus or minus 0.153%. This should be the C. Okay. Suppose you have ignored plus or minus sign. So what is the mistake that you are doing? I am asking what is the accuracy of the instrument. You are supposed to say plus or minus 0.153. Okay. So suppose if you say you ignore plus or minus sign, is it a national crime? Is it a wrong answer? Is it a wrong answer? How it is a wrong answer? Yeah, I'm saying by this plus or minus sign, what I'm saying is, suppose if I measure a temperature of 100 degrees Celsius, I'm saying the error in that instrument or the actual temperature of that instrument can vary anything between 100.153 Kelvin. Here, can you subtract this? Excuse me? 99.847 Kelvin. If I measure 100 Kelvin temperature with the instrument, and my instrument shows 100 Kelvin, and I know the accuracy of the instrument is this, what do I understand is the actual temperature of the medium which I am measuring, okay, could be from 99.847 to 100.157. It could be anything. It could be 100 also. But my instrument shows 100. But accuracy of the instrument is 0.153. So by plus or minus 0.153 percentage, I mean in the actual reading could be from 99.847 to 100.1. Suppose if I ignore this, then what is that I am conveying? This is the answer. This is the right answer. From this to this is the reading that there's a possibility of maximum error that instrument can make. Maximum error that instrument can make. Yesterday we also gave another interpretation of accuracy, isn't it? Right now, suppose I have not given plus or minus sign. What does that mean? Huh? If I don't attach any sign to that number, I assume it is only. What we will understand if I don't give a sign to that number? Positive. Okay. Yesterday you were very indifferent, simply sitting idle, so we sent you out. I hope you will be more interested in the class and participate. The problem is, looking from here, I can understand whether you are mentally here or elsewhere. So please participate in the discussion and get involved in this. Okay. So if by not attaching a sign to a number, I understand it is only a positive number. So what is the answer that I am conveying to my teacher if I don't put plus or minus sign here? That means my error could be anything between the actual reading. The instrument shows 100 Kelvin. The actual reading could be anything between 100 Kelvin and 100.153 Kelvin. Will it be a right answer? Number is same. You could say, sir, I just missed plus or minus sign in the hurry. But the answer is wrong. The meaning that you convey is wrong. So plus or minus sign is important. Okay, in the hurry I forgot to put percentage sign. Is it right? What do I mean? when I measure 100 degrees Celsius, the error could be 0.153 Kelvin. Percentage means per cent. Cent means 100. Per 100. That if it is a temperature, it is per 100 degree Kelvin or 100 Kelvin. If it is pressure, maybe per 100 Pascal, whatever. It is always per 100, that unit of measurement that you have expressed for. So percentage is always for 100. For 100, how much is the error is what we say. Okay. Suppose you don't put percentage, then what you convey? Whether you measure 100 degrees Celsius or 1 degree Celsius or 500 degrees Celsius, the error could be only 0.153, a fixed amount of error. That is also possible for an instrument. That is also possible for an instrument. Always it will have only this error. It's not per degree, per 100 degrees Celsius. Okay. It is also possible, but that's not the answer for our question. That's not the answer for our question. Our question is for the given set of readings, compute the accuracy. So if you don't put percentage sign, you mean a fixed quantity of plus or minus 0.153. If you don't put 100%, only measuring 100 Kelvin, your answer is right. Suppose I am measuring 150 Kelvin. If you don't put percentage sign, then you cannot tell what is the range of actual temperature that you will have. Okay. So your answer is valid only for 100 Kelvin if you don't put percentage sign. Okay. You have to put percentage sign so that it is valid for all the readings that you take using conversion. So in case such questions comes in the examination, two things you have to be very careful. One, compute for all readings, compute the accuracy using the formula. Find out which is the maximum, and don't forget to put plus or minus sign and percentage. If you have computed accuracy using full scale deflection, don't forget to write full scale deflection. FSD is a well-known acronym, so you can use FSD. You don't have to write full scale deflection. You can write FSD. FSD means full scale deflection. But here we have used true value, so you should not write FSD. If you write FSD, again it is wrong. If you use FSD, again it is wrong. So you should not use FSD here, because here our reference value is true value. We have used true value as the reference. So many things in simple form. Any doubts, questions you want to ask about accuracy? Yeah. Yeah. It should be more accurate, but it will be because it is always expressed with the See this, he is telling, sir, when we measure a smaller value and bigger value, here the inaccuracy is more. See, I have taken a reference value of 350. One reference value. With respect to that, I have a medium, exactly made into 350 Kelvin. Okay. And I am using my instrument to be calibrated. This is the instrument to be calibrated. I expose the temperature to that and then read. First time I am taking reading, I am getting something. Second time I am taking reading something. With that, I am computing the accuracy. This is only computed at 350 Kelvin. This is an example problem for you to explain the working of how to compute accuracy. In factory, normally they won't calculate for only one fixed value. They will range from, let's say, if the range of the instrument is from minus 40 degree, minus 0 Kelvin to 500 Kelvin. They will take it in steps. So true value also will vary for each of this computation. Here it's an exam based, so we have given only one true value and the corresponding 10 different values. To be very precise, for every true true value, they will take 10 such readings, take the maximum. Second value, let's say 10 degrees Celsius, 10 different readings, take the maximum. 20 degrees Celsius, 10 different readings, take the maximum. And then out of all this maximum, take the maximum. That's how they compute the equation. It's a tedious process. So here we take this only one for a sample calculation. How to apply that in the formula and express it. That's the purpose. It's an illustrative example. Okay. So 10 degree also you will have any questions? Any other questions? Straight over. Now, percentage of error. A term very closely associated with accuracy is percentage of error. Often people get confused or interchangeably they use. You are not supposed to use. The term percentage of error, you look at the definition or the meaning, it looks more or less accuracy. It looks more or less accuracy. It refers to the deviation of the measured value from the true value, and it is numerically given by true value minus reading or reading minus true value divided by reference value into 100. Okay. Is the formula is not same as the accuracy formula? Yes or no? Right? Only thing which is not there is that modulus is not there, max is not there. Okay. Otherwise, the formula remains same. The formula remains same. So reading minus true value divided by the reference value. Okay. Whatever is the reference value you want to use. Same two reference value into R. What is the difference between percentage of error and the accuracy that we have learned just now? Accuracy is the term attached to the instrument that you are measuring. This is an instrument. I did so many experiments as I explained to him, and then assigned a number plus or minus 1% accuracy for this instrument. That will remain valid till it is further calibrated. The plus or minus 0.1 degree plus or minus 1% accuracy is valid till next it is calibrated. Okay, it won't change. It is the characteristics of this particular instrument. It is something like star rating that we give for a particular player. Okay, MS Dhoni or Kohli, his strike rate is, let's say, 125, 140, whatever it is, or something like that we give. That is for the player. Okay. Whereas the percentage of error is attached to the reading that we have taken. Okay. One such instrument, there are many such instruments sold. I bought one instrument to my company. I made my first measurement, and I know the actual temperature is, let's say, 150 Kelvin. I used this instrument, and then I found the temperature of this instrument shows is 149 Kelvin. So 149 to 150, 149, you substitute here, divide by reference value into 100. I'll get some 0.1 or point something as a error, isn't it? As a error. That is the error in this particular measurement, in this particular reading that I have taken. This reading has that error. It is not the error of the instrument. It's not error of the instrument. Error is in the reading. It is not this. So percentage of error is attached to the reading, and accuracy is attached to the device, the instrument. Okay. So percentage of error tells how much the red value differs from the true value, and it is always attached to the reading. Percentage of accuracy is always attached to the instrument. Otherwise, the meaning is same. Accuracy tells the maximum error that can be produced by this instrument. Error is the error produced today, this particular time. Okay. Strike rate tells what is the on an average, or what is the strike rate of that particular batsman. Today he is not in a mood, or he didn't have a concentration. He goes and then duck and then come out. That is error. In today's error. Okay. Or he might even strike at the rate of 200 strike rate today. That is today's error. Okay. But his strike rate is the accuracy. You understand the difference between error, percentage of error and percentage of accuracy? Okay, percentage of accuracy attached to the instrument, percentage of error is attached to reading. That's very important. Another term, anyway, this is not part of characteristics of instruments, but often people get confused is the tolerance. What is the difference between tolerance and accuracy? You are all mechanical engineers, right? So tell me, what is tolerance? Huh? What is tolerance? Sorry?
Small deviation that can be neglected.
Value?
Small deviation that can be neglected.
A small deviation that can be neglected. Is it that the small deviation is coming, so you have no other go, but then you are neglecting, or you already decide that there will be some error, so I will be neglecting that error?
There will be.
Huh?
So there will be some errors.
Okay, is that you compute and then decide the tolerance, or you simply assign that to? Is it computed or is it assigned? Assigned. Okay, good. How? Can you elaborate? Yeah, good. I am designing some mechanical instruments. I know in the design, in the modeling software, you might have used some dimension, 25 mm or 25.32 mm, whatever, something. Is it possible to manufacture the exact dimension that you have designed in your CAD model or modeling software? It's not possible. There are manufacturing variations because of our incapability to produce or the machine's incapability to produce to the exact size. So we know if I use this manufacturing process, this much variation will be there. And tolerance is what is the maximum amount of deviation I can tolerate. Okay, so that I should tell. If you cross that, then I will have some difficulty in meeting the functional requirement of that problem. That is tolerance. So I know such problems will come during manufacturing. I'm a designer, I'm designing. So I foresee the manufacturing difficulties and then assign how much. This is actually supposed to be 25 mm, but plus or minus 0.2 mm is alright due to manufacturing. I am assigning that maximum permissible error that I can tolerate during the manufacturing deviation. That was the number that we assign. I am not computing from readings. Okay, I am just assigning that number based on my experience and the standards guidelines. The number which tells the maximum deviation that is possible, that is permissible during the manufacturing process is called tolerance. Many people confuse with tolerance and accuracy. So that's why we just want to bring it into a clarity. Range. That's very simple. Suppose you buy an instrument, you can measure from minus 40 degrees Celsius to 100 degrees Celsius. What is the range of the instrument? Huh? Sorry? 100 and? Yeah, that's a small thing. That's called span. You have another term to describe that. Span. Whatever I describe is actually range. So range of the instrument is minus 40 degrees Celsius to 100 degrees Celsius is the range of the instrument. What is the span? Span is the higher calibration value, the highest value that you can measure, minus the lowest value that you can measure. So 100 minus of minus 40 is 140. So minus 40 to 100 degrees Celsius, that's the component. So 140 degrees Celsius is the span of the instrument. Minus 40 degrees Celsius to plus 100 degrees Celsius is range of the instrument. There are two terms that confuses us, and that's how we do it. Okay? So you have range, that's basically a lower calibration value to higher calibration value. That way also you can put. I took higher calibration value to lower calibration value, because the next term talks about higher calibration value minus lower calibration value. So I want to keep the order same. Only minus sign you put in place of 2, so I just put that. Okay. Otherwise it's span. So you understand the difference between range and span? Any questions? It's clear? Fine. Now calibration. Okay. This is a big topic. Calibration is a process of relating the output of the instrument to the input of the instrument. Output of the instrument to the input of the instrument. How do you relate output of the instrument to the input of the instrument? Is basically a calibration. This is the actual meaning of calibration. But if you go to industry, you say, hey, send this instrument for calibration, man. Tell. Okay. That is called recalibration. That is called recalibration. There is a calibration, recalibration. First we talk about calibration. In industries, suppose you are all going to be an engineer in a manufacturing company or an engineering company where you bought some instrument and then using it for 6 months. After 6 months it is supposed to be calibrated. You send the instrument for calibration. What you are basically doing is recalibration. They also talk about calibration, but that's recalibration. Normally calibration means it is linking or connecting the output and input of the instrument. That's calibration. Let's take an example. See. This is, I've drawn a little bigger because it's easy for me to draw and you will be able to see it better. Somewhere you have seen this? What is this? Yeah, thermometer. What is this? Of course, if I draw like this, probably you will be able to. Probably you'll be able to easily identify it. Okay, fine. The enlarged portion of this is this. So your thermometer. Okay, all of you should be familiar with this. Okay. So here you have either alcohol or mercury, and basically a liquid. And then here there's a thin capillary tube, and normally it stays somewhere according to the room temperature. Okay. So you have a liquid and liquid powder. You expose this bulb to a higher temperature. Okay. Basically you expose to higher temperature. What happens to the medium inside? You expose to delta T. Okay. Now it is the reference temperature, let's say room temperature. You expose it to higher temperature, delta T. Proportional to delta T, what happens to the liquid? When heat is added, temperature is added to a liquid, not temperature, heat is added to a liquid, what happens to the liquid?
Expands.
Huh? No.
Expands.
Yes, yeah, it expands. So it expands. So proportional to the temperature, there is a change in volume. There is a change in volume of the liquid. And because of volume, of course, it raises. Okay. So this purposely we make volume as delta area and into delta distance or delta x. That this is the area. Area times length. Some length parameter is this. And cross section. This is cross section area of the tube. We make it as small as possible so that the delta L is enlarged. Very large height for a small temperature. Okay. For a smaller temperature difference, there is a smaller change in volume naturally, and even that we would like to read it easily. So purposely we make this cross-section area small so that you will be able to read this. Just suppose you don't make this A small, Suppose you don't make this A very small. It's not very thin tube. It's big tube. If it is a big tube, the change in the height will be very small. So you will not be able to read easily. There will be expansion, but we will not be able to read easily. If you make A small as possible, L will be more for a given temperature. So you can easily read from this state to this state to that state. There is a scale here that you will get. Okay. So I have delta T added, delta T change in different temperature. Because of that, there is a change in length here. Okay. Now I kept the thermometer in ice, warmed something I took as 0 degrees Celsius. I kept the same thing in a boiling water. I warmed that as 100 degrees Celsius. And then from 0 degrees Celsius to 100 degrees Celsius, I divided equally into 100 equal parts. So now each division will represent 1 degree Celsius. That is how the Celsius scale was developed. This is the finest example of understanding the calibration process. Okay. Now this gap is physically divided into 100 equal parts. So each division is related to 1 degree Celsius. So now I have parameter called temperature. I want to measure when the temperature increases, exposed to the higher temperature, there is a change in volume. I have converted that into change in length. Actually, length I can say change in height because it is vertically measured most of the time. So it's a change in height. Now, if I put 5 degrees Celsius, I may have 1, 2, 3, 4, 5. This 5 units of height, the liquid level will go high. Okay. So now I have calibrated this as 5 degrees Celsius, this as 10 degrees Celsius, this as 50 degrees Celsius, 100 degrees Celsius. Of course, equally, since I have not drawn properly, the graduations of the scale will be there. So my input to the thermometer is temperature. Output to the temperature is the height of the column. Height of the column of liquid, thermometric liquid. So the height of the thermometric fluid minusculus is the output. Temperature is the input. So calibration is the process of linking the temperature to the height of the liquid. From here to here there should be a mapping, proper mapping. If I give 5 degree, it should stop here. And I should link properly. If I have not linked properly, it will show and stand somewhere, some reading is there, but that is not anyway related to the input parameter, that means it is not calibrated. Okay, now here we have temperature as input, height of the column as the output. I know if this is the temperature, this will be the height, and I am linking that as I explained now. Okay, so this process of linking input parameter to the output parameter is called calibration. It's called calibration. For temperature, especially thermometer, this is the process. For various other parameters, physical variables, the process will be slightly different. So you should learn how to calibrate your pressure gauge, how to calibrate distance pressure gauge, all that separate. Okay. So in general, a generic definition of calibration is the process of establishing the relationship between input variable and output variable, or input signal and output signal. There are two types. One is the static calibration, other one is dynamic calibration. Okay. What is meant by static calibration? Suppose I perform this exercise here, right here, under the fan, doors open. There is a huge air flow. There is a fan running and blowing the air. Now, of course, it is sunny, but sometimes it is windy. Humidity may be high, low. Allow all environmental conditions to vary, and then do this calibration. Okay. This calibration we call it as dynamic calibration. This calibration we do it. We call it as dynamic calibration. We establish the relationship between input and output variable by allowing all environmental conditions on its own. We don't purposely do anything. Static calibration means it is in the laboratory conditions. Let's say 23 degrees Celsius, 55 humidity, atmospheric pressure 1 bar exactly. So light, only so much of lighting, cleanliness, so much of cleanliness. What all parameters, all environment, you keep it under control and then perform the calibration. You call it as static calibration. You call it as static calibration. All environmental factors are under control. Performing the calibration is static calibration. Just like that, you perform anywhere, you call it as dynamic calibration. Is that clear? Yes. What question do? I have instrument A. This is calibrated in static condition. I have instrument B performed calibration in dynamic condition. Dynamic calibration. I'm an engineer in an MNC. I would like to choose an instrument. Okay. That is statically calibrated, dynamically calibrated. Now, I wanted to choose one among them. After calibration, both of their specs looks almost similar. Exactly. Why almost? Exactly similar. A and B looks exactly similar. But one manufacturer says he has calibrated static calibration. Another manufacturer says he has performed dynamic calibration. That's the only difference. The rest all remain same. Spec, price, quality, everything looks same. As an engineer, will you choose A or B?
B.
Raise your hands. A. How many of you feel you should choose A? Okay, how many of you will choose B? Why?
Because everything we can show the wires static.
Why you will choose B? It's always better to choose dynamic calibration. Why? It can be used anywhere. Beautiful. Good. Very good. You started listening. Dynamic calibration is, you don't have to maintain same temperature, same humidity, all conditions in your company to take exact reading. Because it is already dynamically calibrated. Nothing is kept under control. You simply allow everything to vary. Like you can bring that to your factory. There may be some furnace there. There may be some dust producing melting process going on here. You want to use here, probably you can use this. Okay? A little far away from furnace. Of course, not very close to that, but a little far away from furnace. There is this, humidity. So sometimes there is a spraying unit and humidity is high. That's a usual thing in many of the factories. Whether I can use this inside the factory, yeah, without any trouble you will be able to use, provided if it is dynamic calibration. It will be more rugged. Static calibration means what? It gives the stated specifications. It performs as per the specifications given by the manufacturer, provided you maintain the same static calibration conditions. 23 degrees Celsius, 55 humidity, relative humidity 55%. Of course, all other environmental conditions, you keep it at the specified value, then it gives the performance. Otherwise, the performance is not stated. The performance is not stated by the manufacturer. He doesn't give any guarantee. He gives guarantee for that particular. You maintain this, my instrument will give you this performance. That's the guarantee for static calibration. Dynamic calibration, no sir, you simply use it anywhere, sir, no problem. My instrument will give that performance stated in my closure. So, dynamic calibration is better calibration as far as a buyer we are concerned. So normally, the manufacturers don't say whether it is statically calibrated or dynamically calibrated. Unless they do dynamic calibration, they simply say it is calibration is done. That's all. So you have to specifically pull their tongue and then ask whether it is static calibrated, dynamically calibrated. Then only they will open their mouth. So they are diplomatic. This is time already. Okay, we'll stop here. And then rest of the term